In this video and in the next few, we're going to talk about some shortcuts that we can use to speed up the process of using the chain rule. Now, if you really like using that four-step process, if you're really comfortable with that, then you can continue to use that four-step process. There's nothing wrong with it, but I do want to just mention these shortcuts and show them to you so that you can use them if you like. So the first one is going to look like f of x equals u raised to the nth power. So in these types of problems, we're going to have u equals some inside function g of x here. So we're going to have some inside function g of x raised to the nth power. Now I would look at this and say, that looks a lot like just x to the nth. So I would expect its derivative to look pretty similar to that. So if we apply our power rule, f prime of x, our derivative would be n times u, and then we subtract 1 from our power, n minus 1. But remember, this u is really a function. We have to remember that we're using the chain rule here. And the chain rule says that after we find the derivative of the outside part, we need to multiply by the derivative of the inside part, u prime. So we can take the derivative of that, quote, outside function, just like we normally would using the power rule, and then just multiply by the derivative of that inside part. One thing that I really want to make sure to point out, notice that u, that kind of inside part of our function, is actually going to reappear in our derivative. That's going to stay exactly the same inside of our exponent. So we're going to practice some examples here using this shortcut. The first problem we've got here is f of x equals 1 over x to the fourth minus 1 raised to the third power. So here you might look at that and say, that doesn't really look like u to the nth power. That looks like 1 over u to the nth power. But remember that we've got those exponent properties that say I can take an exponent that's in the denominator, I can bump it up to the numerator, I just have to make it negative. So this I can rewrite as x to the fourth minus 1 raised to the negative 3 power. So if you're not up to date on those exponent rules, I highly recommend going back and looking at them and practicing working with them a little bit more, because it is going to make our work in this section and the rest of the course a whole lot easier. So now this looks like u raised to the nth power. I still maybe want to identify what is my inside function. So my inside function in this problem is going to be x to the fourth minus 1. So now let's just jump into our derivative, f prime of x. So what did we say? We said we're going to start by multiplying by our power. So we're going to multiply by negative 3. So we should have negative 3. What happens next? We're going to have u. That's the same. So the inside part of our function is going to stay exactly the same. So we're still going to have x to the fourth minus 1. Then what? Well, then we subtract 1 from our power. So negative 3 minus 1 should give us negative 4. Be careful when working with negative numbers here. So we have this whole piece now. The only thing that we're missing is times the derivative of that inside part. So I need to multiply by the derivative of our inside part, which we said in this problem was x to the fourth minus 1. So I'm going to multiply by our derivative, which in this problem would just be 4x to the third. There's our derivative. At this point, I'm just going to do a little bit of simplifying. I can multiply negative 3 times 4x to the third, since they're both monomials. So here we can write this as negative 12x raised to the third power times x to the fourth minus 1 to the minus 4 power. Now, if you wanted to leave your answer like that, I think that's perfectly fine. I'm not a fan of negative exponents. I think they're difficult to work with, and I think there will come a time in which we're going to want to rewrite with positive exponents. It's going to make the rest of our problems easier. So I'm going to take a step just to rewrite this as negative 12x to the third power divided by x to the fourth minus 1 raised to the fourth power. Either one of these answers I think is fine if you were doing this problem on like a quiz or an exam or something like that. But I do think it will be helpful for us to have these positive exponents eventually, so I think it's a good skill to start practicing sooner rather than later. And there we go, we've got our derivative. Let's look at one more example here. Next, we've got f of x equals x squared minus 6, square root of x squared minus 6. Here, again, this might not look like u to the nth right away, but remember those exponent rules, they tell us how we can take a radical and rewrite it as a power. I can rewrite this square root as x squared minus 6 to the 1/2 power. And now this looks a lot more like u to the nth. So I know I need to identify my inside part. In this problem, it's going to be x squared minus 6. So let's try using our shortcut here. And I'll write that off to the side over here. F prime of x is equal to n times u raised to the n minus 1 times u prime. So what do we need to do here for our derivative? We're going to start by multiplying by our power. So we multiply by 1/2. The inside of our function, x squared minus 6, that stays exactly the same. So 1/2 times x squared minus 6. We need to subtract 1 from our power here. So 1/2 minus 1, we're going to end up with negative 1/2. And then we need to multiply by the derivative of our inside part. So the derivative of that inside part would just be 2x. So at this point, we've got our derivative. I'm just going to take a step or two to simplify this now. So 1/2 times 2, those are going to cancel out. And then let's see, we'll have f prime of x is equal to x times x squared minus 6 raised to the negative 1/2 power, which you could leave your answer like that, that's fine. But if you like your positive exponents like me, we can also write this as x divided by x squared minus 6 to the positive 1/2 power. Again, either one of these is fine for right now, but I do think it's a good idea to start practicing rewriting with positive exponents for future problems that we're going to be looking at.